Hello everyone, you are welcome to today's class. So today we want to look at similar shapes. So under this topic, we'll be looking at this. Number one, we want to look at what are similar shapes. Then after that, we look at how do we identify if two shapes are similar or not. Then three, we want to use this similar shape to find size of shapes. So that's what we want to learn in this video. So let's look at what similar shapes are. So two shapes will be similar if they have the same property. Just like you have a circle. This is a circle, right? And this is another circle. As you can see, this circle is bigger than this. So this circle is an enlargement of this. So if this circle is an enlargement of this, we'll say that these two circles are similar. But that doesn't mean that the two have the same size. They have different sizes, but they are similar in the sense that they have the same property. So now, if we have, for instance, we have another shape. This is a triangle. We have another triangle here, right? So these two triangles, we cannot conclude that these two triangles are similar because there are some things that are hidden here because they are not drawn to scale. We don't know that if this is an enlargement of this. So until we are able to meet some conditions before we can conclude that these two shapes are what similar. So we're still going to look at that in this video. So what we're going to do now is this. We're going to be basically focusing our attention on triangles. Focusing our attention on triangles. Similar triangles. Let me put it that way. Similar triangles. Similar triangles. So two triangles will be similar if they are equiangular. If they are what? Equiangular. Meaning that the two triangles must have the same angles. We have three angles in a triangle. This is one, and then this is what? Another one. So which means that the angles here, if this one is 30, so we must have out of this, let's assume this one is also 30. Then if this one is 120, then one of these two angles must also be what? 120. Once we are able to meet, we are able to see two of these angles being equal to any two of these other angles here. So we can conclude that these two triangles are similar because automatically the third angle will be what? Equal, because some of angles in a triangle is 180. That means this is what will be 60, while this also what? Be 60. So that is the first condition. The second condition is that the ratio of corresponding size must be equal. Must be what? Equal. So this is the second condition. So the first one, we're done with the first one. The second one is that the corresponding size, the ratio must be what? Equal. So ratio, as you have known before, ratio is when you have this side, which is, let's say this is x, so it corresponds to what? To this side. As you can see, we're still going to explain that in details. Let's say to this one. So that means the ratio will be then x over what? Over y. This is ratio. So ratio of this, another side to this side must also be equal to what? To this. We will explain that later. So these are the two conditions we must meet before we conclude that two triangles are what? Similar. The first one, they must be equiangular. At least two sides of the two triangles must be equal. Then the ratio of corresponding sides must also be what? Be equal. So from here now, we now go to how to identify corresponding sides. Identification of corresponding sides is very key to the understanding of similar shapes. So once you fail to identify the corresponding sides, you find it difficult to solve the problem. And it's so easy to identify. So let's look at this. We have this triangle. I'll give different examples. I will make use of this first one. Let's have this. We have this. Now, this place, let me give it one curve here. and let me give you another curve, same curve. Then let me have 2 here, and let me have 2 here. Then let me have 3 here, and let me have 3 here. So the implication of this is this. It's possible in a question you see this will be displayed like this. And it's possible that you'll be given the exact angle. Sometimes you'll be given 2 angles here, 2 angles here, but 2 different ones. So we now need to find the third one to see if you are going to get the same angle straight. We get to that stage. Now, as you have here, let's label this one to be angle A, B, C, and this one to be X, Y, Z. Now, we want to get the ratio of corresponding sides here. Now, side AB, from here, it shows that this angle is equal to this angle. This angle here is equal to this angle, as you can see. Then this angle here is equal to what? This angle here. So that doesn't matter if you have A here. This doesn't mean that this and this are equal, this and this are equal, and this and this are equal. You can see the way I did it, so that you'll be able to know that it's not every time this will be equal to this will be equal to this. So it can be anyhow. So that being said, so let's now start from the side. These are the side we're looking for. We are saying this is the side AB, AC, BC, XY, YZ, and XZ. So we want to see the corresponding side. So from here we can conclude that AB corresponds, right? Corresponds to which side here in triangle XYZ? AB. So you can see from A we have 2 curves here to what? 1 curve. Where do we have 2 curves? We have 2 curves to 1. That is YZ. So this corresponds to what? YZ. I hope this is clear. I'm moving from A to B. That is line AB here. So what I have on A, angle A is we have double, and angle B we have single. So in angle Y we have double. That means A. Then Z, which is this. So that means AB corresponds to what? YZ. That's the first one. Then the second one I can start from anyone. I can pick BC or AC. So let's say BC corresponds to BC, that is 1 to 3. 1 to 3. That is what? 1 to 3 ZX or XZ. Still the same thing. So I'm writing XZ because I'm trying to write it alphabetically. In some textbook, it's not necessary, but let's put it alphabetically. I can write ZX, still the same thing. Then let me pick the last one. I'll pick this. The last one, which is AC. AC corresponds to AC. This is 2 to 3. 2 to 3. That is what? X, Y. I hope this is very clear. So that is how to identify corresponding size, right? After that, we have identified the corresponding size. It now means it remains the ratio. So let's look at the ratio here. Ratio of corresponding size. Ratio of corresponding size. So what I will just be picking this AB, which corresponds to YZ. That is the ratio. The ratio of this one is AB divided by YZ. It must be equal to the second ratio, which is called to BC divided by X what? Z. Which must also be equal to the third one, which is what? AC divided by what? X what? XY. So that is how to identify the corresponding size of similar triangles. So the next stage now is now to see how we can use this to solve problems. So try as much as possible to give you at least 3 examples in this video before we conclude it. So example 1, triangles ABC, ABC and PQR are equiangular. PQR equiangular. That is, they have equal angles. As you can see, This angle equals to this angle. This angle equals to this angle. Why this equals to this? Right? So calculate AB, this, and what? AC. Is that clear? So the first thing we need to do here is to write out the ratio of corresponding what? Sides. So how do we do that? Just the way we have said, we will pick from AB. This is AB. So that was the first thing. AB corresponds to which side here? That is 1, 2, 1, 2. That is what? PQ. It must be equals to BC. You notice one thing. I started from this one to this one. You can either start from here to this or start from here to this. You still get the same answer. So BC to BC, which is 2 to 3. 2 to 3. This is R. 2 to 3. That is what? PR or RP. Then the last one, which will be AC. AC, right? AC, that is 1 to 3. 1 to 3. That is what? QR. So we want to find. So the next stage is to put the values so that we know what we're looking for. So AB, we don't know. Let the AB be X, AC to be what? Y. To be easier for us. So AB is what? X. Then PQ, 20 centimeters. BC, 5 centimeters. PR, 12 centimeters. AC, that is Y. QR is what? 8 centimeters. So we have this. So we have three ratios here. So the next stage for us to, if you look at this, out of the three ratios, this is the only one that is completed, right? So what we're going to do, we just match this, we combine this to this to find the value of X. And at the same time, we pick this and this one to find the value of Y. So let's start with the first one. X divided by 20 equals 5 divided by what? By 12, right? So what we're going to do, when we cross multiply here, this multiplied by this, that gives us 12x equals 20 multiplied by 5, 20 times 45. There's no for you to multiply because you're still going to divide, right? So in that case, this divided by 12, divide both sides by 12. So 12 cancel 12, we have x here, right? So 4 can go here, 3. 4 can go here, what? 5, which means we have 25 divided by what? 3. So that means the value of x will be 2 in 25, that is 8, right? Which is 24, remainder 1 over 3 centimeters. That is the value of our x. That's the first stage. So the second stage is this. We'll combine this, the one that is complete with this. That means we're going to have 5 over 12 equals y divided by 8. We cross multiply the same thing. So that will be 12y, 12 times y equals to 5 times what? 8. So that is 12y equals what? 40. Divide both sides by 12. By 12. Cancel, cancel. Then we have this. So 4 can go here, 3. 4 can go here, what? 10. So we have 10 divided by 3. Then y will then be equal to 3 whole number 1 all over 3 centimeters. Then you can convert to decimal. So that is how to find the value of. So we can therefore say that x, which is AB, we can therefore AB equals 8 whole number 1 over the, that's 8.3 centimeters, while the AC is what? 3 whole number 1 over 3 centimeters. So that is our final answer. That's for example 1. Example 2 here. So we have calculate the length marked with by letter. So which length is marked by letter? I think this is it here, right? Which is SP. But before we do that, so we need to look at it. Can we conclude that we only have a shape, which is a triangle, then we have two lines that are parallel. How do we solve this? So what should come to your mind is that here, how many triangles can we bring out? This is one here, SPQ, and the another one, STR. So the first thing you need to do here is to bring out the two triangles. We are going to bring out the two triangles. That's the first job here. So in doing that, I'll just bring this out. The smaller one, which is this. Now, mind you, if you fail to, you can decide not to bring it out, but the best to do is to bring it out so that you can get, you will not make mistake. So SPQ, right? Then the second one, which is the bigger one, is this. Sorry. So labeling is the most important aspect. That's S, T, and what? R. Now, this angle is here, which is S, which is S is also here, S is also here. They are the same. This S here is the same thing as this S. Now, if you look at this, these two lines are parallel. So, and when you have two lines parallel and you have a transversal crossing it, so we're going to come up with this. This angle here corresponds to this angle. This angle corresponds to this angle. That is corresponding angles. That means angle P equals to angle T. So P equals to what? T. So also, but the corresponding angle gives F. As you can see, F that is upside down this way. Can you see? This is it. F. This is another F upside down. This angle and this angle equals to this angle. Right? So that means this equals to what? This. So in examination, this is what you are expected to do for you to be able to bring out the ratio of corresponding sides correctly. So then we can then put the value of the size. This 12 centimeters. Then this is X. This one, ST here. Mind you, you have to be very careful here. SP is X, while PT is 5. So we have to add the two together. That will be X plus 5 will be what? ST. While SR will be the addition of 12 and 7. That gives what? 19 centimeters. I hope this is clear. So the next stage is to write out the ratio of corresponding sides. So let's start with this. SP corresponds to, that is 1, 2, 1, 2. Correspond to what? ST. Then SQ corresponds to SQ, which is 1, 3, 1, 3. Corresponds to what? 19. Sorry, SQ first. And the third one, which is PQ, corresponds to, that is 2, 3, 2, 3. That is TR. So let's now put in the value. SP is X, ST is X plus 5 equals SQ, which is 12. Sorry, I made a mistake here. SQ, then SR. This is SR. Sorry. So that is 19. PQ, we don't know the value, and TR, we don't know the value. So which means we don't need this. So we only going to make use of this. From here, we cross multiply. This multiplied, that will be 19x equals to 12 multiplied by x plus what? 5. So we open that is 19x equals 12x, right? 12 times 5, that's plus 60. So we collect like terms. That's 19x minus 12x equals to what? 60. So 19x minus 12x, that gives what? 7x equals to what? 60. So we divide both sides by 7, by 7. 7 cancels 7. Then x equals to 8.57. So that's 8.57 centimeters. Use your calculator, you get that. So that is that on the example 2. So third example. So we asked to calculate BE, which is this side, and the shape below. So let it be Y. Let it be Y. So the first thing we need to do here is to bring out, separate the triangles. So we're going to separate them now. We separate them. I'll bring out this first, right? I have A here, I have D here, I have E here. So this is 7 centimeters, this is 6 centimeters, and we given this angle here to be this, and this is this, with nothing here, nothing here. So we leave it like that. So the second part, which is this, right? So we have A, then we have B, C. This angle is given as 1 here, and this is what 2 here. So then we have this place 6 plus 12. That gives, this place gives us what, 18 centimeters. That is AC. Then AB will be 7 plus Y. Y plus what, 7 centimeters. Then BC, which is what, 15 what, centimeters. From here, this is straightforward. So we can have the ratio of corresponding sides here. So let me start with AD. AD here corresponds to 0 to 1. Nothing here, nothing is here. That will be 0 to 1, 0 to 1. That is AB. Then AE, which is 0 to 2, 0 to 2 corresponds to what? AC, right? Then ED, ED corresponds to ED, that is 1, 2, 1, 2, that is BC, right? That is that on that. Then write the values. AD, which is 6 centimeters, then AB, which is Y plus 7, then AE 7 centimeters, AC 18 centimeters, then ED, we don't know ED, and then which one again? ED, we don't know ED, and a BC, which is what, 15. But mind you, what we're looking for is this Y, which is EB. EB is Y, and Y is here. So this is complete. We don't need this one. So we just make use of this when you cross multiply here, right? So cross multiplying will give us 7 into Y plus 7 equal to 6 multiplied by what? 18. So I can decide to divide both sides by what? There's no, let me open the bracket. That is 7Y plus 49 equal to 16, 6 times what? 18, which we can calculate to be 6 times 8, 48. That is 108. So the 7Y plus 49. Then we have 7Y equals 108 minus 49. So that means 7Y. So when you subtract this, so this is 9, 59. So divide both sides by what? 7. Divide both sides by 7. 7 cancels 7. Then, because of space under, so Y will be equal to 59 divided by 7. That means Y will be equal to 7 in 59. That is 8. So it remains, that is 49 plus 7. That is 56, remainder 3 over 7 centimeters. So that's the value of Y. So we can then conclude that EB, what we asked for this BE, therefore BE, which is line BE, equals 8 to number 3 all over 7 centimeters. So that's how to solve this problem. So subsequently we look at some other questions and so similar shapes. So this way we're going to stop the video. We stop it here. Then if you have not subscribed to my channel, don't forget to subscribe, and you find this video useful and helpful, so give me a thumb up so that you can encourage me to produce more of this video. So thank you very much for your attention, and we'll see you in the next video. Bye bye.